if you integrate 2 cos x, does it become 2 sine x?
Mm-hmm.
And the 3 over x is the same as 3x to the power of -1.
Mm-hmm.
So if you integrate that, becomes just 3x.
What is -1 plus 1?
0,
X to the 0 is the same as?
1, so just 3.
You'd think so, but definitely the derivative of 3 isn't 3 over x. I believe it's a special one, 3 ln x.
Oh.
It's a special one. And how about this one?
So that's the same as minus x to the power of a half. So it will be x to the power of 3 over 2 over 3 over 2.
And over 3 over 2 is the same as?
I'm not sure.
Keep change flip. Divided by 3 over 2.
Times 2/3.
Yeah, so I'll write it as 2/3. Okay. And then at the end, plus c. Let's see. There's a lot going on here. Sure is. Well, do I look for stuff for this? I bet I better. 1 second. This is year 2. Is that a Google search? Okay, so we want 11.1. Yeah. Oh, it's weird time. Okay. Why did he do this to me? Let's do it. Okay, let's try A. For the first part, I think we need formula booklet. Are you allowed to use it? So 3 sec squared x. So there we've got this one.
So 3 tan x plus c.
So that's going to be 3 tan x. Okay, how about these two?
That's the same as 5x to the -1. So plus 5 ln x.
Mm-hmm.
And that is the same as 2x to the -2. So 2x to the -1 over -1.
So, yeah. 2 over -1. That's x minus 1. And you could simplify it. I think you'll be alright. Okay, let's try this next one. B.
Do we have to get the sine squared x off of the bottom?
Yeah, it would help to do that. Let me just make space for this one. Put that there.
I'm not sure.
Another way to write it is cos x over sine x sine x. What is cos x over sine x? same as?
Tan to the -1.
Let me just see before I start doing this. Is there a... Might be. Alright, what is tan to the -1 the same as? I hope you don't mean arctan. What's sine over cos?
Tan.
What's cos over sine?
Tan to the -1.
And what's the special name for tan to the -1?
The inverse.
It's not the inverse. That's what I was afraid of. The reciprocal one is called cotan or cot. So that there is cos x over sine x and times 1 over sine x. Right? Redemption. 1 over sine x is the same as... Has a special name.
Cosine.
Cosec.
Oh, yeah, cosec.
And so we have to integrate cot x cosec x. Is that anywhere?
Minus cosec x plus c.
Well done. That is minus cosec x. And then integrate second part.
If you integrate e, does it say the same?
Yep.
So I'm not sure.
What's the derivative of 2e to the x?
Two x to the power of e.
It is.
No, ex.
It is 2e to the x, kind of a special one.
Oh.
And so integral?
Stay the same.
Yeah. So what is it?
2e to the power of x.
Yeah. Plus c, because it's being integrated. That's it. So we work out the trig, and then we check formula. Minus cosec x minus 2e to the x plus c. Alright. How do we do this?
So it's like a definite integral, but there's a lot of stuff in that bracket.
I'm just thinking. 6 squared L1. Let me see these formulas. Is there a way to make this simpler? Sine squared x plus cos squared x is identical to 1. So how would we get cot? We'd have to divide by sine squared. So that would be 1. That would be cot squared x. And that would be cosec squared x. Does that help? Sec. Oh, I don't know. Wait, is this by parts or something? Why are they doing this to me? Let's just expand the bracket, see if we can figure something out.
Okay, so sec squared x cot squared x minus 3e to the power of x sec squared x cos squared x minus sec squared x.
Okay. So let us now change everything into sine or cos. So for example, tan is sine over cos. So what could everything be written as in terms of sine or cos?
Wait, what do you mean?
So like, what is sec squared x the same as?
1 over cos squared x.
So that's 1 over cos squared x. What is cot squared x the same as?
1 over tan squared x.
Yeah. And in terms of sine and cos?
Oh.
So tan is sine over cos, and so cot.
So would it be cosec over
Cot is the reciprocal of tan? Tan is sine over cos, cot.
cos over sine?
Yep. Over sine. Or in this case, for this one, cot squared x.
Cos squared over sine squared?
So cos squared x over sine squared x. Alright, keep going. So 3 to the x. This one is already cos squared x. Okay, sec squared x.
Same as 1 over, no wait. Yeah, 1 over cos squared x.
Yeah. And this
minus 1 over cos squared x.
Yeah. So that isn't really affected by anything. Let's just leave sec squared x for now. Because I have a feeling that because that's minus, that's just a separate integration.
Okay, yeah.
It would all work out. Alright, simplify. Anything we can simplify. You know what? I'll write it as 1 over. Yes, anything we can simplify.
I don't think so.
I don't think so. 1 over cos squared times cos squared over sine squared.
Cos squared x over sine squared x cos squared x.
Right. What's cos squared over cos squared? Anything divided by itself?
1.
Let's see. Okay, anything you can simplify the next one?
No.
Caoilfhinn. That's the same thing.
But isn't that attached to the 3e to the power of x?
It doesn't matter.
So would that bit just become 3e to the power of x?
Yep. And so that bit there is 3e to the x. So now let's change everything back. 3e to the x. So what is this bit here?
Wait. 1 over sine squared x.
And what is 1 over sine squared x the same as?
Cosec squared x.
So that's cosec squared x. That's minus 3 to the x. And this one was still minus sec squared x. Formulas, we have cosec squared and we have sec squared. Are they there?
Cosec squared x is the same as minus cot x plus c.
Yeah. Oops. So that is minus cot x. This one?
Say the same.
And sec squared x.
Tan x plus c.
That's it. Minus tan x plus c. That's it. Oh, that's not it. And then we have to do this integration here. How do we do that? Between pi over 3 and pi over 6.
So for the first bit, you sub in pi over 3 for x, and then you minus it from if you sub in pi over 6 for x.
Yes. Pi over 3. And they wanted exact value. And so you'd have to do each one separately. 3e to the pi over 3, I think, will give you a decimal. And so that would just be in your answer. How would you put cot pi over 3 into your calculator?
1 over tan x.
Yeah, 1 over tan to the pi over tan of pi over 3. That's, what is this thing? Minus tan pi over 6. And you put the whole thing, you have to put them all in separately to get the exact value. I think you're okay for the last part?
Yeah.
Right, let's see. So that was bananas. Before we move on, let's see. Okay. Let's see, sec. Let's try. Yeah. Let's try these. So how do you do first one?
Do we have to expand the brackets?
Yeah, I'm just gonna move it. Hang on. Put it there. Alright, expand the first bracket. What do you get?
Please can you move it over to the right a little bit?
One day it's right, next day it's left.
So sine x plus sine x sec squared x.
Mm-hmm. Sine x sec squared x. It isn't there. So what do we do?
Do the sine x and sec squared x separately.
Right? How do you do that?
With their formulas.
No. That's a different type of integration, like integration by parts. It's like the product rule of integration. You stay away from that.
Okay, so
how did we deal with it in this one? So we had to integrate sec squared x cot squared x. How did we do
it? We rewrote them as 1 over cos squared x and cos squared x over sine squared x.
Yeah. Change everything into sine or cos.
So the sec squared x will become 1 over cos squared x.
Mm-hmm. What's next? We can multiply.
Oh, okay. So we get sine x over cos squared x.
Which you could write as sine x over cos x, if that helps.
So tan x cos x.
Yeah. Well, tan x times 1 over cos x. If you follow me.
Yes.
What is 1 over cos x? Same as.
Cosec x.
So that is. What's the third letter of cos?
S.
Yep. So it's not cosec, it's sec.
Okay.
Tan. So another way to write that is sine x plus that. Tan x sec x. Is that there?
Sec x plus x.
Hang on. Sec x plus c. And so, integrate.
Does sine x become minus cos x?
Yeah.
Then I forgot what it was.
Get you the man. Plus, I think it was sec x plus c. That's it. Turn everything to sine or sine and cos, and then you go from there. All right, question F.
You know, with all of these questions, do you only have to write add C like once?
Yep.
So, you know, if you use two of the equations, you know how they both say plus C, you only write it as plus C and not like plus 2C.
Yeah, it's because what is the derivative of x cubed? Sorry, x cubed plus 7.
3x squared.
So that is 3x squared. Okay, what is the integral of 3x squared?
X cubed.
It's x cubed and it's plus c because you don't know what if there was a number there. And that's all that's all the plus c is doing. Like saying plus 2c would be meaningless because we can't know what the number is.
Okay.
Yeah. Okay. F.
We expand the bracket, so cos x plus.
So okay.
And if you do cos x times 1 over sine squared x, we get cos x over sine x, which is the same as cot x.
Mm-hmm. And the other one?
Cos x, so that becomes sine x.
You didn't fully write this one over here, I believe.
Oh,
1 over sine x.
Cos x over sine squared x. Okay, so cot x times 1 over sine x, yeah.
All right. What is 1 over sine x the same as?
Cosec x.
Yeah. So how do we integrate cot x cosec x?
With a formula?
Hope so. Cot x cosec x.
Minus cosec x plus c.
Minus cosec x plus c. That's it. All of these are going to be similar. Break it down fully to sine and cos. Simplify and then unbreak it down again. Put it back into being the reciprocal trig functions. Cosec, sec, cotan, whatever. Any of these formulas. Want to do more, or you think you get the idea with these?
I kind of have the idea.
You'll practice. Let's see. Right, stuff's about to get real. How about this one?
Please, can you move it over a little bit?
You have to move these back again and then.
Okay, so it's another definite one. But okay, so firstly would you do x to the minus 1 brackets 2x plus 1? And then expand, so you just get, if you times x to the minus 1 by 2x, you just get 2.
Yep.
Plus x to the minus 1. Then if we integrate 2, then we get 2 squared over 2.
Hold on. This is embarrassing for you, not me. Derivative of 2x.
So like differentiate. 2, just 2.
What is the integral of 2?
2x.
Yep. And so this one?
It will be 2x.
It'd be 2x, not 2 squared over 2 or whatever malarkey. This one?
X over 1.
What is minus 1 plus 1?
0.
So what do you do there?
Becomes 1.
But obviously the derivative of 1 isn't x to the minus 1. It has a special integral.
Ln.
Yep.
X.
Yep.
Is equal to ln 12.
Yep.
Then I'm not sure what you would do next.
Sub in 3a for x. And then
minus sub in just a
yeah.
is equal to ln 12.
Don't want the exact value of a. How do we do it?
Expand the brackets.
Mm-hmm.
So 6a plus ln 3a minus 2a minus ln a equals ln 12. So if we simplify that, we get 4a plus ln 2a equals ln 12.
4a plus plus ln, what's it?
Ln 2a.
What is the rule for subtracting logs?
Do you do something with like dividing?
Yep. Three
Ln 3a over ln a minus ln a.
over a. Like that. Simplify.
4a plus ln 3 equals ln 12. So 4a equals ln 9. So
She learned nothing.
ln 12 over 3.
What's 12 divided by 3?
4.
So 4a is ln 4.
So a is ln 4 over 4.
Yeah, I'll just do a quarter of ln 4. So we don't accidentally do ln 1 or something. A quarter of ln 4. Let's see this. A quarter of ln 4. Got it. And you can check your answer as the decimal, but they wanted the exact value. So you can't just use the calculator. Right. Very happy to see another one of these. Let's do it.
So firstly, we do x to the minus 1 brackets 3x minus 1, and then I have to expand that. So x to the minus 1 times 3x is
You're good.
3, just 3. Minus x to the minus 1, and then now to that, then we sub in 2a for x.
You didn't integrate it yet?
Oh, whoops. Okay, so if we integrate 3, we would get 3x. And if we integrate that, is it minus ln x? And then now can we sub in 2a and then minus sub in a?
Do it.
So,
Or, alright. Simplify, I suppose.
6a minus ln 2a minus 3a plus ln a. So then we just get 3a minus ln a equals 6 plus ln a half.
How did you get ln a?
So minus ln 2a over a.
That would be if it was minus ln a. This is plus ln a.
Oh, do we times it?
Yep.
So ln 2a times a is ln 2a squared.
Yep. Squared. Yep.
So we want to get a by itself. Wait.
We do want to get a by itself. Why did they make this tricky? Maybe it's a bit too tricky. Did we go wrong somewhere with a minus? 3x minus 1. That's x to the minus 1. That's 3. That's minus x to the minus 1. That is a minus ln 2a. didn't get, oh, you got, hold on. 6a minus ln 2a. So ln 2a minus becomes plus. So ln 2a plus ln a. So they split that up into ln 2 plus ln a. They moved it to the... Should still work. They used some snake in that. 2 ln 2. It'll still work. You can move the power to the front. 2 ln... No. That's a bad idea. I get it now. I get it. The way you'd go about this is you'd split that in two, and you'd say that's ln 2 plus ln a squared.
Okay.
But before we do that, let's do that step but further back. How would you know to do that? I don't know. So back at this point, before we got the squared, that's when, ln 2a, 3a minus, so ln 2a, how else can you write that?
I'm not too sure.
You could write that as ln 2 plus ln a. So that is 3a minus ln 2 plus ln a, because that would multiply to give you like ln 2a. And expand that negative bracket. So expand that bracket by -1.
Minus ln 2 minus ln a.
Yep. And simplify.
3a minus ln 2.
Yep. So 3a minus ln 2. Yeah. And that'll be a simpler way to go about this. So when you have 2a, if you don't get rid of a, just split it into two different things and simplify it. Keeps things simple. All right. Solve.
So 3a equals 6 plus ln 2.5.
I don't like that. 3a is equal to 6 plus ln. How did you... You chicken this, man. So ln a half plus ln 2?
Yeah.
Law of log. What do you have to do?
Times.
Times. What do you get?
You do a half times 2.
Yep.
Yeah, 1.
Yeah.
A equals 6 plus ln 1 all over 3.
All right. What's 6 over 3?
2.
And I'm going to write the other one as a half ln 1. Hunch time. Ln 1. Ln 1 is 0. And so what is A?
2.
go. Equals 2. So ln 0, ln 1, they have like special values. So we get 2. There we go. Oh wow, calculator even gave 2 for that one. There you go. Alright, so laws of logs in reverse. Ln 2a is same as ln 2 plus ln a. Laws of logs forward. Ln a half plus ln 2 is ln a half times 2. When do you see two powers being added?
When you add logs.
Alright. Or at GCSE, you saw it when copy the base, add the powers. And so logs are just like index numbers. So if you see them being added, that's when it's one times the other. Oh, I don't want to do any more of these, do you?
No.
Yay. Let me see. It's similar. Let me just see what's after this. Oh, we do, don't we? Right. How about this?
I think if you integrate e to the x, it stays as e to the x. So e to the x plus e to the minus x.
And what is the derivative of minus x?
If you differentiate minus x, minus 1.
And so the chain rule would be, the derivative of that would be e to the minus x times minus 1. And so the integral is e to the minus x divided by minus 1.
Okay.
Let's see, that's equal, so that's what? Ln a ln 1 equals 48 over 7. You have to find a. How do we do it? What's next?
Substitute ln a for x minus substitute ln 1.
Yeah. Just so you're aware, I hold my breath when I'm listening carefully. And so you're going to make me pass out. Calculator, ln 1.
0.
Right, that's what I'm doing. Otherwise I'll faint. Okay. What is e to the ln a? Any ideas?
No.
You're cheeking this, man. Right, e to the ln 37. What are you cheeking me for? Brackets. Right, e to the ln 37 is 37. What do you think e to the ln a is?
A.
I can breathe. Okay, next one.
Is it minus a over minus 1?
I think so. Okay, this one.
1
Mm-hmm.
plus 1 over minus 1.
Yep. Next.
A plus A over 1 minus 1 minus 1 over minus 1.
Okay.
So A divided by 1 is just A.
Mm-hmm.
So 2A, and then put the other bits on the other side. So 48 over 7 plus 1 over minus 1
Mm-hmm.
is the same.
Sure is.
48 over. So A is 48 over 7 all over 2.
All right. What's that?
24 over 7.
48 over 14. 28 over 7. Is that what you said? What'd you say? 24 over 7?
Yeah.
Yep. 24 over 7. That's it. 24. Nope. That's all wrong. Is it?
Oh.
Shouldn't be. Where did we go wrong? Where did you go wrong? E to the minus ln A. E to the minus ln A. That's E to the ln A to the minus... Oh, it's A to the minus 1, not minus A. A to the minus 1. Which is 1 over. Let me see, that was... Hold on. That's because it was mine. Right, let's start this one up the top.
Does it stay as 3e to x?
Yep.
Plus 6e to the minus 2x?
Let's see. Plus 6 e to the minus 2x divided by derivative of function inside function.
Function inside function.
Uh-huh. That's the function inside the function. Derivative of minus 2x.
Minus 2.
Yep. Minus 2. And that's a much easier question than before. That's between b and 2 equal to 0, and you solve it. Those are easier. Let me see. Solve this equation. That ln one, I need to move to the end or something. Let me make a note of that. Not that one. This one is a much trickier one. Let me just quickly do some stuff. e to the ln b. What is that?
Ln b.
Nope.
Oh. I'm not sure.
What's e to the ln 37?
37. Okay, just b.
Just b. And alright. Yeah, what do you give yourself there?
A half.
I'll have you. Let's see. Your difficulty is with exponentials and logs, not integration. That's what you need to work on. If you want, we can do the next integration next time, or which is the kind of chain rule that we looked at a little bit, or we can do exponentials and logs, or we can do something else, or you can let me know. Any preference?
I'll let you know.
All right. Any questions for me in general?
No.
All right. Well done, Keelan. It is great, and I look forward to chatting again next week.
Thank you. Have a good week.
You too. Take care.